Hello, this is the video from the review preview lesson 4.1.3. Solve each of the following systems algebraically. What do the solutions tell you about each system? Visualizing the graphs may help you with your description. So let's use the substitution method for part A. We've got y equals 3x minus 5 and y equals 2x minus 15. So we already know that y is equal to this part here, so I can go ahead and substitute it in for y in the other equation. So this will become 3x minus 5 equals negative 2x minus 15. Let's add 2x to both sides. So we have 5x minus 5 equals negative 15. Add 5, so 5x is equal to negative 10. Divide by 5, so x equals negative 2. Okay. So to find our last point, we just plug that into one of the equations. Let's take y equals 3 times negative 2 minus 5. That'd be negative 6. So then y equals negative 11. Okay, so what that tells me is the lines intersect at one point. We have our one solution. Okay, lines intersect at one point. And you could easily type that into Desmos too and take a look. All right, for part B, let's use the substitution method again, but let's get this y by itself. So let's add that 7. So I rewrote it to be like that. So now that I have y alone, I know that's what's equal to y, so I can plug it in there. So this becomes 4x plus 2 times negative 2x plus 7 equals 14. 4x minus 4x plus 14. Oh, interesting. So if I minus the 14 here, they go away, and 4x minus 4x is 0. So we have 0 equals 0, which you're going to see that means that there are infinite solutions. Go ahead and type it into Desmos and take a look, because they're the same line. The equations are equivalent. Okay, so for the next ones, let's just go ahead and type these into Desmos. We've got y equals 2 times x plus 3 squared minus 5, and y equals 14x plus 17. So I see that we have an intersection here. Let's see if there's any others. Got one here. And I know that there's one right up in here somewhere. And there. So we've got an intersection at 245 where the lines touch, and at negative 1, 3. So I'm going to write here that they intersect, oops, sorry about that. There we go. They intersect twice, and we've got 245 and negative 1, 3. And keep in mind, which we just saw, this is a parabola. It's got the squared, and this is in y equals mx plus b form, so that's just a line. All right, similar idea here. Let's go ahead and type that into Desmos. So we have y equals 3 times x minus 2 squared plus 3. I know that's going to be a parabola. And then we have a line, y equals 6x minus 12. And it looks like they intersect right in here somewhere. Let's see. I know it's at 3, 6. If I can get it to pop up. Here we go. 3. There we go. Right there at 3, 6. All right. So intersect. Ooh. Fix my iPad. So they intersect at 3, 6. Okay, Let's go to 4-41. It says solve each equation below. So here I see that we have that squared. What I'm going to do is use one of our techniques to solve versus just thinking about it maybe like what we would have done in chapter 2. So we've got 3 and then y plus 1 squared equals 48. We're going to divide by 3. So we have y plus 1 squared equals 16. Then I'm going to take the square root on both sides to get rid of that squared. So this becomes y plus 1, but we need to be careful because when we take the square root, that's plus or minus 4. Okay, so that's going to give us 2 answers when we have a question like that. So let's split it up. So we can make y plus 1 equal 4 and y plus 1 equals negative 4. So y equals 3 if I subtract the 1, and y equals negative 5 if I subtract the 1. Right. Part B, I've got that square root there. It's in my way, so I'm going to do the opposite and square it. So I have 1 minus 4x equals 10 squared, which is 100. Subtract 1 on both sides, so negative 4x equals 99. And I'm going to divide negative 4. This ends up being, you could just leave it as negative 99 over 4, or you could make it a decimal, but this works just fine. Okay, here. Let's start, we've got 6y minus 1 over y minus 3 equals 2. Let's just get rid of this 3 right away. So we have 6y minus 1 over y equals 5. I need to get rid of this y in the bottom, so I'm going to multiply it on each side. So I have 6y minus 1 equals 5y. Let's subtract the 6y. So negative 1 equals negative 1y, divide by negative 1, so 1 equals y. Oh, we have a 5th root. This is different this time. So to get rid of a square root, re-square. To get rid of a 5th root, we'll take everything to the 5th power. Okay, so we have 1 minus 2x equals 3 to the 5th power. Do 3, that little arrow above the division sign, to the 5th power is 243. We'll subtract 1, so negative 2x equals, and you can subtract 1, which is 242. And then we'll divide by that negative 2, which is negative 121. All right, 4-44, we're going back to finding the slope. So remember, y equals mx plus b. M is your slope, b is your y-intercept. So your slope here, or your m, is negative 6/5. And your y-intercept, your b, that's at negative 7, so we'll write 0, negative 7 for the point. Okay, this one almost looks like y equals mx plus b, so let's move things around a little bit. Let's subtract that 3 and then divide by negative 2. So y equals 3 over 2x minus 5. So your slope is 3 over 2, and your y-intercept is 0, negative 5. All right, so the line that goes through these points. So I like to, when we need to find the slope, do my x1, y1, x2, y2, so we can use this formula to find the slope. So y2 is 4 minus negative 2y1 over 8 minus 5. So this becomes a plus, so 6 over 3, which is 2. Okay, so what we have so far is y equals 2x plus b. Well, we need a slope and a b. So take one of these points. Let's do 4 and 8 because they're both positives. So I'm going to plug those in for here. So we have 4 equals 2 times 8 plus b. 4 equals 16 plus b minus 16. So negative 12 equals b. So our final equation then will be y equals 2x minus 12. The slope equals 2, and your y-intercept is 0, negative 12. Okay, and I think that's all for the 4.1.3. And watch the next video for lesson 4.1.4. Thanks.